Good afternoon, everyone. Thanks very much for joining our VBC climate lecture today. Before we start, I would like to give you a very quick introduction about us. I'm Riccardo from the climate group. I will briefly share a slide. This is some information about today's talk and our group. We are a grassroots initiative founded at the end of 2019 at the Max Perutz Labs in Vienna. Our goal is to promote sustainability in science at the Max Perutz Labs Vienna Biocenter. Here you can see a link to our YouTube channel where you can see our previous lectures. And also you can find more information on the website, and feel free to send us an email for any other information, requests, question, if you want to network, collaborate. So I will stop sharing now. And I will give you an introduction about today's speaker. Today we have Professor Helga Kromp-Kolb. She's a meteorologist and Professor Emeritus at the University of Natural Resources and Life Sciences at the BOKU in Vienna. Her expertise lies in the fields of climatology, environmental meteorology, air pollution, climate change, and sustainable development. For her, contributions at the intersection of science, politics, and society. She has received many awards, such as Scientist of the Year in 2005, Decoration of Honor for Services to the Republic of Austria in 2013, and the honorary doctoral degree at the TU Graz for her tireless commitment to climate protection and sustainable society in 2022. The title of her latest book is also the title of today's climate lecture. Is it too late for pessimism? I have the book here. I don't know if you can see it. There's a bit of blurring maybe. I would highly recommend it. But more remarkably, the subtitle of the book is We Are Part of the Solution. So today we will learn how we can all contribute to solving the climate emergency. With this, I will leave it to Professor Kromp-Kolb. And please feel free to write down any questions on the chat anytime, but you can also ask them in person at the end of the talk.
You're still muted.
Okay.
Okay, yes. Okay, I'll leave it to you. Yeah. Thanks a lot again.
Thank you very much for having me and for inviting me. And thank you all for your interest. I think it's a topic that concerns us all. And I put a question mark at the end because I hope that we can discuss things at the end of this lecture. As it is not something where I can give you all the answers, but I have a lot of questions, and I hope we can discuss them and maybe together move a step forward in answering them. So imagine yourself, you're doing research on some problem of interest, of scientific interest, and as a byproduct, more or less, you find that some sort of substance that is used in everyday life has some additional, so far unknown consequences for, let's say, health of people. And at first you're skeptical, then you look at this in more detail and you delve deeper, and you become convinced that there's a real problem concerned in using this substance. And while at first you published this in journals, relevant journals, and your colleagues first disputed it, and then they found, well, there's something to it. And in the end, it's sort of accepted knowledge amongst your scientific community. Well, society doesn't react. And you start writing popular articles, giving lectures, and everybody says, oh, and nobody reacts. It just stays with that's interesting, and oh, how awful, but nobody reacts. Nothing is done. There's no regulation passed. Nothing is really done. So what do you do as scientists? Do you just continue with your normal research? Do you follow your career as originally planned? Is it something you feel more responsibility for? Well, this is the kind of situation the climate scientists find themselves in. They have, meanwhile, done about 40 years of research, and well, there's no reaction that is appropriate to the results of their research. And of course, you ask yourself questions, maybe we're overestimating the consequences of the changes we are expecting, or have we not communicated sufficiently clearly? Have we communicated the wrong things? Have we talked about ice bears instead of about floods in your own hometown? What do we need to communicate and how? Do we need to create fear about the future, or do we need to emphasize solutions? Does somebody else have to communicate? Maybe it's not scientists at all. But is it about communication? Or are there interests and power structures underlying the situation that no matter how you and who communicates, nothing will happen? And what is the task of science, of scientists, and of universities in this situation? This is the reality that we are facing, and this is a reality that is being discussed amongst many of the leading scientists internationally, not just in Austria. And of course, there's a different set of questions now in the United States, but essentially, it's the same basic problem. Is society well informed about our scientific results? And if so, why is it not reacting? And can we just accept that it's not reacting? So this is sort of a background to my talk today. In my view, and in the view of most of my colleagues, is really a fundamental problem that is not only a natural science problem, it's a societal problem, and it's also a problem for educational system and for the scientists. And it's a communication problem. It's also had something to do with scientific skepticism. It sort of ends in the question, are we doing the right thing? Is it okay to just keep researching, publishing in high-ranking journals? Is that sufficient in view of what we know about the future we're heading to? But why is the climate issue so central? And maybe I should talk about this a little bit before we come back to the questions I just posed, and then we can discuss them. Well, if we look at the past, the climate in the past, we see that the climate has always changed, which is one of the things that the so-called skeptics claim, and they are completely right. And we need to acknowledge that. We need to acknowledge that they are right. Climate has always changed. The question is how much, when, and why. And if we look at this graph, it goes back to 500 million years before the present. And in the vertical, you see the temperature, and the horizontal is the time scale, which is stretched as we get closer to the present on the right-hand side of the graph. And what we can see is that temperatures were much, much higher than they are now. About 500 million years ago, 400 million years ago, 300 million years ago. But there were no humans. The first humans appeared somewhere in the black part of this graph, some few million years ago. I think it's not finally established exactly scientifically when humans began, but it's also a question, what do you call a human? When does a human become a human? But no matter how you decide this, we find that now we are heading towards those temperatures. or we have already exceeding them, depending on when you put the starting point. But the other aspect is that whenever you put it, even if you put it at 5 million years before present and temperatures were a bit higher than they are now, we had few humans and a lot of nature. So the scientists, the economist Herman Daly calls this the empty world. And we now have a full world, a world with a lot of people and little nature. And we still have the same economic thinking of the empty world. This is one of our basic problems, that we still think that humans are entitled to use as much of nature as they want because there's so much of it. They can pollute the atmosphere because it's so huge. Dilution will solve everything. The same in the oceans. Dilution will solve all the problems. Well, we have learned that that is not true. There's too many of us and too little of nature, and we're polluting at a too high rate. Well, back to this graph. We are now at the end of a period of about 10,000 years with rather constant temperatures. What we call the Holocene. And at the beginning of the Holocene, there were, well, a few million people, and now we're a few billion people. So even in this period of time, things have changed considerably. And we're heading for temperatures, these are the red dots, which are higher even than they were at the beginning of when humans developed. So yes, climate has always changed, but during the time humans really developed and the population grew significantly, climate has not changed that much. Temperature has not changed that much. The Holocene was a rather long period of constant temperatures. And this is probably one of the reasons why our highly developed civilizations were possible at all. But let's get closer to the present, to what's happening now. And you can see here a graph of the temperatures, globally average temperatures. And starting by the 1970s, we have a more or less linear increase of temperatures. They vary from year to year. We have a high variance there, but we have a rather linear increase in temperature, or we had until about, well, it depends how you want to interpret this, but about 10 years ago. And the last few years have been much, much warmer than we had expected them to be, following this linear increase. The linear increase puts us somewhere near about 1.2, 1.25 degrees Celsius compared to pre-industrial level. The average now puts us somewhere to 1.4 degrees Celsius, and the last year reached 1.6 degrees Celsius, which is above the aim, the goal, one of the goals of the Paris Agreement. Paris Agreement says we obliged ourselves as nations to keep the temperature well below 2 degrees Celsius and to make efforts not to let temperature rise significantly about 1.5 degrees. So if those 1.6 are an indication, or the warming of the last 10 years is an indication of where we're heading to, then we have obviously already exceeded the 1.5 degrees Celsius, even if you take a long-term average, because with increasing temperatures, the average will not drop below 1.5 anymore. So things are moving faster than we expected. These last few years have put our understanding of the climate, not so much the climate system, but of the parameters that govern it, and possibly of the feedbacks that are involved, have put those in question. And I can't tell you at the moment what the answer is. There's some colleagues that say, well, this is just an extraordinary disturbance and it's a chaotic system. It will come back down and we'll be back on track along the green line. But those voices are becoming fewer as new information comes in. It seems that we have underestimated two parameters: the sensitivity of temperature regarding carbon dioxide concentrations, but also regarding aerosol concentrations. and the aerosol concentrations cause cooling, the carbon dioxide cause warming. And if you miscalculate or misinterpret both, then for a period of time, this can sort of, the errors can cancel each other. And it seems now that aerosol concentrations are going back, but the data is not sufficient to really say this with any certainty. But it seems that they are dropping, and therefore the warming part now really becomes more important. And since we have wrongly estimated this, we see the consequences now. If that is the explanation, that means that future temperatures will rise faster than the green line implies, and it's a systemic change. And the same goes if what we also observe, the cloud cover of the ocean changes. That is observed. The question is why that is so. It's also a high parameter with high variability, but it could be a feedback mechanism from climate change. And if that is so, then it would also mean that temperature rises will be larger than anticipated. Now, we thought we understood the system, and the implications were scary. And we find that our understanding is flawed because we can compare models with reality and they don't match. And the possible implications are even more scary. The basics are still valid. This has not put the climate models as such in question, but the parameters and the feedbacks might be insufficiently understood. Now, if we look at Austria and what's happening in Austria, you can see that in this graph, it has sort of the dashed line, and the black line is what has happened in Austria so far, how temperatures have developed. And you can also see here the temperature rise beginning in the 1970s. And what the models expected, if we just keep going as usual, business as usual, would be some development along the red, within the red part, in the red area. And if we attempted to achieve the Paris Agreement with staying below, well below 2 degrees and not exceeding 1.5 significantly, we would have to move in the green part of this graph. And the reality is the black line. And what you can see that in the year 2025, temperatures have reached a value that in the red part would only be reached in about 15 years, maybe more, depending on what part of that red shaded area you're looking at. And we're well outside of the range of the green shaded area. So the climate is moving faster than our models expected in Austria as well. And the same is, by the way, of course, true for Germany and for Switzerland. And the weather services in Germany, Switzerland, and Austria have discussed how to handle the situation. Because the public sort of thinks science is infallible. And if we now admit that we didn't get it right, then there's the fear that people will say, well, I always said climate models were nonsense and the whole warming issue is not an issue. So there's fear of correcting climate statements, even though this is normal part of science, that you think you understood something, you make your predictions, your extrapolations, and then you find it's not so, and you have to correct your hypothesis. This is normal science. It's normal in science, but it is not what people understand. People expect scientists to know the truth, and we're grappling with that. Nevertheless, of course, we have to admit that we at the moment in difficulties, but it means also that if people ask, well, what it's going to be like in 10 years, what it's going to be like 2040 in Austria, well, we just don't know. We just don't know. It's very difficult to say anything. We used to be rather confident to talk about temperature, but even temperature, we have lost that confidence. We have to clarify what is at the base of this discrepancy before we can feel any substance for information about what's going to happen in next years. Of course, in general, you can say it's going to be warmer. Warming is going to happen even faster, extremes, and so on. But if you need to quantify it, then it becomes difficult. By the way, quantification in general is not really necessary, because if you listen to people, so many people talk about 2% temperature increase. They don't realize that we're talking about degrees and not percent, which shows that there's no real understanding, no real grasping of what we're talking about. But maybe it's not necessary. Just to know we're heading for trouble is maybe good enough. Of course, these average temperature changes are not the only thing. We have a lot of additional problems with extremes. And it's, I just noticed this graph is partly German, but I think it's well understood by any scientist. We have a shift of a normal distribution, of a Gaussian distribution, which remains a Gaussian distribution, but it moves towards the hotter part. In this case, it's temperature, because temperature is the simplest and most symmetric of our parameters. And what we can see is at the same time, variance increases. So future means are higher than past means, but at the same time, what was considered extreme heat will become much more frequent, and we will meet with temperatures we never had before, while cold, low temperatures still remain an issue, maybe not as frequent as they used to be, but frequently enough to cause difficulties, for instance, with frosts in spring, ruining the apricot yield, and so on. One other aspect or one example of these extreme events, you probably all realized last September, the middle of September, the top graph shows in the green lines over many years the precipitation values for the area that's depicted in the lower graph, essentially centered around Austria. And the red line is what happened last year. And you can see in the middle of September, we had this enormous amount of precipitation, an amount of precipitation that one of my colleagues, I happened to be on holidays at the time, one of my colleagues, Petra Seibert, called or sent an email saying, look at those models. I never realized they could produce so much precipitation in so short a time. Well, it really happened. By the way, this was also a very good example of what Jim Hansen called science reticence, which means that scientists tend to be very conservative is not the right word, very cautious in their statements, because she sent this mail to me on a Sunday. And the precipitation occurred in the week afterwards, Friday, Saturday, Sunday especially. And she commented, apart from look at the model, she said, Austria is going to go under. I immediately turned on the news and tried to find out what the news says, and they didn't say anything. And they only started discussing this on Wednesday. And that means that 4 days were lost for preparation. It's not quite true, because the Weather Service did inform all the necessary organizations like fire brigades and so on, but they did not inform the general public. And the reason is that they are afraid if they warn of extreme events that then don't occur, if that happens 2 or 3 times, then people will not believe them if they warn of extreme events. But this is, of course, not an ideal way to handle such situations which have potentially high consequences. Because anybody whose cellar and ground floor was flooded would probably, in retrospect, have liked to know that a week before, and they would have started moving all their various belongings to the upper floors to save them. Of course, if scientists had been wrong, if the models had then sort of changed the signal, and it would have turned out that it would be just a normal rainfall, then they would have done all that work for nothing. But I think that people would prefer doing that for nothing once or twice, it's not that often, rather than losing all of these things. And this is something where climate scientists, and especially in this case, the Weather Service, needs to cooperate with the public to get a better understanding of probability statements, saying we have, according to our models, a certain risk of this happening. This is a week ahead of time. Models are uncertain if you look so far. It is your personal decision whether you want to prepare for this event or whether you want to wait. We will keep you posted. But this is not the way information at present is being presented. And I think that is one of the problems we have, that our public is not well informed, does not well understand how science works, and that it is not a question of we know, but we sort of have our methods that indicate, but it might be wrong. So this just as a side aspect. On the whole, we have to say that the unexpected becomes more likely. And that means that people have to take more personal responsibility, because the government or the local authorities cannot prepare for every possibility, and especially not for things which were considered impossible so far. So this is something there needs to be more responsibility also placed on the individuals and also placed on local authorities. And I remember when the forest fires in Australia a few years ago, I saw a video posted by one of the heads of the fire department. And this man stated very, very clearly, either you get out now, or we cannot guarantee you that we can help you. You might lose your life, and we can't do anything about it. And I think that is something we also need to make clear to people. You are not safe, and somebody will rescue you, no matter what happens. Things are occurring that we cannot handle, and you also have to take your own precautionary measures. And you have to think about what will I do in which case. So I think that is something of science, society interaction that needs to be done. And this is, I mean, I'm talking about climate, but I think the same things are relevant for many other aspects in everyday life and science as well. Now, all of this is problematic in climate, no question. But what really makes the thing very urgent and very, very, and sort of puts it at the top of the list is that there are self-reinforcing processes in this climate system. And the danger is that tipping points will be exceeded that systematically change the systems. So what are the feedbacks? Well, the well-known feedback, the ice albedo feedback, it's getting warmer for whatever reason, and ice melts, the surface becomes darker. That means solar radiation absorption is increased. That means it will get even warmer, which means more ice melts and so on. So this keeps going once it's triggered. And typically these reinforcing processes sort of start out slowly, and then they become faster and faster. Exponential growth is what describes these processes typically. Of course, there's also balancing loops that sort of go up and down, and sort of undulate around the stable situation. But they are, at the moment, the weaker processes. It's these reinforcing processes that really will determine our climate future. And there's not just the ones I posted here, there's many others as well. And this is what's really problematic, because in the beginning with the slow development, you think, well, there's plenty of time. Once you really notice the exponential growth, it's too late to do anything. And then tipping points can be reached. Tipping points means it's sort of like the melting point for ice or snow. If you increase the temperature, snow melts, and you have water after that. And if you decrease the temperature again, this water will not turn back into snow. It will turn back into some sort of lump of ice. So the system has changed. And this can happen in many subsystems of the climate system, and therefore also in the complete climate system. So what we're facing now is a decision of whether we want to try to stabilize climate. 1.5 is passed, but maybe at 2 degrees. It takes a lot of effort to do that. Or whether we accept not to stabilize and accept constant warming. We call this hothouse Earth. And the decision is taken now because the 1.5 degrees possibly are already exceeded, but they will certainly be exceeded in the early 2030s, probably much earlier in view of the changes we have seen in the last few years. That means that if we want to stay below those 2 degrees, we have to take measures that take effect in this decade and not sometimes in the next or the decade after that. This decade is crucial. That means, for instance, if I don't know, you're hopeful of a new type of atomic energy, fusion maybe, or these small modular reactors that are so popular now, none of them will become available in any significant number before the 2040s, probably, maybe 35 or so. It's all too late. So no matter whether you're a friend of nuclear or not, it won't help in solving the climate issue because it's just too late. You might say, well, that's because, and so on. That's not the issue here. The question is, it does not contribute to the solution of the immediate climate problem. This makes the climate issue very special. There's one other issue which might be of a similar urgency, and that is biodiversity loss. But I'm no biologist, I'm no specialist in that. It's just, well, a popular discussion between climate scientists and biologists, whether the one or the other will lead us to destruction first. Yeah, but the issue is we need to combat both. And this combating is not a scientific problem. This is a societal problem. And the issue is that climate changes might be explained in a natural science way, but what's underlying is a societal problem. My colleague Reinhard Steurer says, if a society, I don't know, I start the other way around. If politicians don't act on scientific advice, on scientific results, then they have to be replaced. And if society is not in a mood or in a position to replace their politicians because they are not acting, then it's a societal problem. That's one issue. It's a societal problem because society does not react. And the other question is that climate change has societal implications, any amount of them. Climate change is essentially a problem enlarger. Problems that exist are becoming more dramatic, more serious with climate change. This is true for societal tensions of all sorts. This is true for war-like situations. It is in our not reacting and in the consequences, it's a societal problem. I want to just introduce one short aspect on greenhouse gas emissions, because that is something that is usually forgotten and not mentioned, and I think this is the right time to mention it. Emissions by military and by military actions. And if we just look at the military without the military actions, I mean without wars or terrorism or whatever you want to call it, the emissions by the military, if taken all together, globally all together, then they make up about 5.5 to 7% of global emissions. We don't know exactly because the military is explicitly exempt from reporting their emissions. That's in the Paris Agreement, and it's one of the weaknesses of that agreement. But that would place it in fourth place after China, US, and India. So it is not negligible. The emissions caused by the military are not negligible. And if you look at war, the war in the Ukraine causes per year more emissions than Austria, something like 30% more emissions than Austria. Again, it's just a very uncertain number because we don't have really good numbers, but international groups have been trying to ascertain what this means. And very roughly speaking, it's about 1/3 of these emissions go back to military actions themselves. About 1/3 go back to the burning of forests, buildings, and so on, and the CO2 emitted by burning. And about 1/3 goes back to reconstruction and, what you need to reconstruct, concrete and so on, steel. And then there's a lot of additional things like migration and other movements, but essentially it's these three components. And I think it's necessary to talk about that because there's another aspect to war that has become more likely or less unlikely, maybe I should say so. That is the nuclear risk. And it was a short period before Christmas when the risk of nuclear war was really great. Maybe it's a bit less acute at the moment, but I think we should know about that. And usually we don't discuss this also. Essentially in the war in the Ukraine, but also in the Near East, it is the nuclear powers that are on the opposite sides. So the risk of nuclear war, even limited nuclear war, and there's a lot of military experts that say a limited war is not thinkable, it's all or nothing. And whatever it is, it means that there will be a lot of burning, and the burning causes soot to rise into the atmosphere. And when the fire is very hot, and that is the case with nuclear bombs, then the soot rises very high up in the atmosphere, and it stays there for a long period of time because as soon as it leaves the troposphere and enters the stratosphere, there's no precipitation to take it out. So it takes very long to be eliminated. And that means that we will have much less sunshine, a reduction in temperature, significant reduction in temperature, and mass crop failures. Since this is a global issue, international trade will not help. The recent results of one model run, again, careful, this is just one model run, and there's a lot of assumptions in it that might be mistaken. But even if you take a factor of 2 or even a factor of 10 as error, it's still dramatic. The bottom line here says that about 500 million people would die immediately through the bombs, nuclear bombs, in an outright war between two nuclear powers, Russia and US, for instance, and about 5 billion people would die of hunger in the following period of time. So this means that a large part of of human population would be doomed in case of a nuclear war. And I think it's important that at least we scientists are aware of these things because it has become acceptable to talk about nuclear deterrence and nuclear moving under the nuclear shield by France and so on. I think we need to know what nuclear war means. Nuclear war is not something where those areas are hit, where the bombs fall, bombs are dropped, but it's something which involves the whole globe. And last but not least on this issue, the Agenda 2030 on sustainable development says very clearly that there can be no sustainable development without peace and no peace without sustainable development. And I think somehow we've forgotten that. And if you look at the map showing all the areas that have military or terrorist actions in some way, it is a significant part of the globe. It's not just the Ukraine and it's not just Palestine. And of course, it also destroys trust. And we cannot solve the climate problem without trust between nations. So I think it's really important to also address this issue. But let's get back to climate issue in a more narrow sense. What can we do? Well, in this whole chain of emissions, concentrations, climate reactions, there's essentially 4 parts where we can act. The one is reduce emissions. That is sort of the normal and the logical thing to do. The other aspect would be to try to intervene in the system itself with geoengineering. The third possibility is to adapt to the changes, but that is only possible up to a certain limit. Beyond that limit, adaptation is no longer possible. And also it takes, of course, quite a bit of money. It takes more money than mitigation, which is often forgotten. And finally, we have nature and restorations, which has become very clear in the heated debate about the restoration law in the European Union last year. Nature, I haven't put that picture in, nature, essentially the oceans and soil and vegetation, they pick up about half of the greenhouse gas emissions that we produce, if we let them. And the soil and vegetation make up about, well, a fourth, roughly speaking. So if we destroy these natural functions, that means we will have an increased climate issue, and we will have to do much more to reduce emissions and much faster than we do if we let nature do its part and support us in our fight against climate change. Now, I want to talk mainly about mitigation. So how do we reduce and how much do we need to reduce? What you can see here is a graph about greenhouse gas emissions on the global level. We have the continuous increase since the 1970s, about a bit before that. And that's the gray part. And in order to stay within our limits of 2 degrees, in this case, the graph is for 1.5 degrees. We've already missed that, but 2 degrees is not much different. It means that we have to follow the red line, the path of the red line in our emissions, which means reduce emissions by 50% by 2030, and on the global level, reach net zero by 2050. If Austria says it wants to reach net zero by 2040, that's fine, because the industrial nations should go ahead on that and give more space and room to the developing countries. So that is quite robust science. Of course, it's also based on the models we have so far. So if anything, these models underestimate the need for reduction. It might be much more urgent than we even think now, but that is a challenge that is already a very, very big challenge to achieve that. Because you must be aware that from a world that increases its emissions year by year, we have to move to a world that decreases them dramatically from year to year. No wonder that Angela Merkel, when she visited the Ahrtal, where we had these enormous floods in 2021, said we need full transformation of our way of doing business. And I would say end of thinking, I would add that. Now, I don't know what Angela Merkel meant when she said that. This is just my interpretation. We need to change our energy systems, move towards renewable energies, and this will have consequences for geopolitics, for dependencies between countries. A lot of the money that we are now sending out to countries where it is not put to good use will stay within the country. It will also give us an impetus to rethink many of our actions and our lifestyles, and probably also trigger a lot of innovation. So that would be one kind of transformation that I would envisage. But you can go through the whole list of industry, mobility, infrastructure, agriculture, health system, and so on, you name it, including education system, financial system, and the economic system, and democracy. All of these systems are deficient in some way and could be replaced by better systems, more fit-to-purpose systems that at the same time are climate-friendlier than the systems now. And so essentially what this statement says is that we can do good climate policies and at the same time improve equity, improve quality of life. And I think that's a very important message. It's not something to be afraid of. Essentially, it's also what the Sustainable Development Goals says, that a good life for all within the ecological limits is possible, and that these two have to be reached simultaneously and not be played off against each other. Yeah, I'll skip that. There's also, but if you would like to, we can afterwards go into some examples. And this is also true for our economic systems. First, let's look at, are there positive developments? There are any amount of positive developments. I just want to focus on one, electricity. You can see here the prices of electricity, the different colors, the different forms of electricity. And on the left, all these yellow ones and the blue ones are renewables, is solar and wind and hydro. Hydro must also be hydro is also somewhere around here. Can't see it at the moment. Anyway, they are definitely much cheaper per unit of energy than all the coal, gas, oil issues, and much cheaper than nuclear. So even in Texas, a state that is very much pro-Trump, they are not following the rule of drill, baby, drill, but they are strongly developing solar. They are even ahead of California in this respect because it's just the economic solution. Yeah. But there's also other examples. For instance, this is an example of a small village in Austria, in Lower Austria, Obergrafendorf. And if you look at this, what they have done there in the way of energy, in the way of keeping the money flow within the community by having municipal subsidies in local business vouchers, in terms of food and so on. They have a lot of measures that really increase the quality of life and at the same time are very climate friendly. It means that we have to be inclusive in pulling together politics, individuals, give them chance to participate, and of course the economy. You have to combine all three, and of course you also need the media. Then you can really move forward and reach and get good results. Now the question is, what's the role of scientists and science? We are facing difficult issues and we need systemic understanding, we need emotional intelligence, we need orientation along values, we need convincing visions, we need an inclusive style, having people participate, we need innovative approaches and a long-term perspective. These are not my ideas. This is something which has come out of several studies where business CEOs were asked, what do you need? What do you want from your employees? And what makes a good CEO? And this is what sort of is it's a summary of what comes out of these questions. And if you look at what universities do, well, we don't do very much for systemic understanding. We are organized along disciplines. Then this is the opposite to systemic understanding. Emotional intelligence, well, we still pride ourselves in objectivity, whatever that means, but this has nothing to do with emotions, even though every scientist has emotions. And so we have some discrepancy here. Orientation towards values, well, we consider science to be value-free. Meanwhile, I think it has become clear that science is never value-free, but we haven't really admitted, and we don't really react to the fact that it is not value-free. We need convincing visions, and typically scientists do not indulge in visions. They want to analyze, they want to understand, but it is not a question of creating visions. An inclusive style. Well, I don't think we need to or we need to admit that there is a certain academic arrogance. We do not easily admit input from the non-academic world. We need innovative approaches, and yet we have a sort of peer standardization. If you try to submit a paper with a completely new idea, the chances that it will not be published are very, very large, especially if the idea is complex and not easily understood, because none of the reviewers will venture to say, well, I don't understand it, but let's give it a try. They would rather say, well, I don't want to be caught out or supporting something which is really nonsense. Important as peer reviews are, I'm not questioning them. I'm just saying that they sort of concentrate things on mainstream thinking, and outliers have a very difficult time getting published. And we need long-term perspectives, and this is the opposite to our short-term projects that we have now. So our whole system is not really geared to create the kind of graduate that is needed in the real world. And I think there's one issue which bothers me very much in last few years. We keep talking about trust in science and lacking trust in science. And I think this has a lot to do with the way we ourselves act, and not just with how we communicate. My observation is, and maybe we can discuss this afterwards, my observation is that even in universities, mainstream thinking has become enormously important, and there's very little discussion about outlier views or even opposing views, because essentially we have bipolar positions in many. Either there is a man-made climate change or there's not. There's nothing in between. It's yes or no. And the same is true, I don't know, if you look at the Ukraine war or whatever, or if you look at COVID, yes or no. And this is not what science is about. We should admit all hypotheses. We should test them, the hypothesis, not the proponents, and test them against reality where this is possible, and keep the more powerful explanations for the time being. And if we cannot decide, then we have to accept the uncertainty, and we have to live with this uncertainty. Falsification is, of course, possible at any time and is needed, but based on evidence. And there needs to be transparency in argumentation. And above all, there needs to be a certain modesty in the statements scientists make. Not, we know that. Some things we do know, but most things we just consider to be the more likely solution. And it is not a question of how many scientists think what or say what. It is not a democratic process. And we should keep in mind that all major scientific developments start somewhere on the fringe. They don't come out of mainstream thinking. They come from the fringe and are then move into mainstream thinking. So this should be something we should consider when we are very quick in dismissing views that are not in line with our thinking. That's basically also one of the problems I have with fact checkers. Fact checkers usually don't check facts, but they check opinions, and that is a very dangerous thing. So what is our responsibility? Well, in the first place, since we have such dramatic open issues at the moment, I think our responsibility as a whole community, that does not mean every single scientist, because we cannot, would be again mainstreaming, but as a community, we have to make sure that the questions that are relevant to society are being treated and researched on, and if possible, give answers given. We also should not concentrate too much on what we have done over the last few years, and I include my science. We rely too much on numbers and models that give numbers, and what cannot be quantified is sort of dismissed, but that is not the reality. In reality, we need human-centered solutions. And we need to anticipate what scientific questions will arise. In climate science, it's quite obvious that geoengineering will become a main issue. The closer, the more the crisis becomes apparent, the more likely it is that people want to go into geoengineering. So we need research there, not to propose doing it, but to understand what it means. And this, for instance, also means we need some legal expertise on how to handle that kind of development. Well, and in the end, we also need to make our results accessible, not only to scientists, but also to the public and to politicians. And I think for ourselves, this means that we need more self-reflection. We need to think more about what are we doing, why are we doing, how are we doing it, is it the right thing? Are we not only doing the thing we're doing correctly, but are we doing the right thing? And the same is valid for a system. And that means also leaving the comfort zone. It's not comfortable to talk to people who essentially deny climate change. But we have to do that. I think that's part of our responsibility. We also must make sure that our science is independent. We should not be beholden to any political party or to any economic entity. And we need to strengthen the culture of discussion. I mentioned that before. And essentially, we need to take a stand, which is something scientists were not asked to do over a long period of time, but I think we need to do that. Essentially, in the climate issue, it is clear that we need to make the necessary possible and not think about what is easy now, but we need to stabilize climate and as low a value as possible. And we need to make that possible. And that is much more difficult than just thinking about what could be a possible next step. But I think that's an essential issue. For us individually, it means, of course, that our lifestyle must be somehow in accordance with what we preach. Climate scientists who fly all over the world and who, I don't know, run cars and buy any fruit at any time of the year, they are not credible. So we need to practice what we preach. On the one hand, that is essential for our legitimacy. But on the other hand, we also need to spread information and to enlarge our handprint, which means get out of our ivory tower, talk to people, talk to politicians, and put pressure on politics. Yeah, finally, and I know I'm running over time, but finally, I think there's 3 questions you should ask yourself as a university institution, as an individual, but also as a city, as a country. The first question is, what is really important to us? What we want to keep in view of climate change, in view of combating climate change, which means that we will have to do with about half the energy that we have now. If we want to be climate neutral CO2 neutral by 2040, we will have about half the energy available that we had so far. So how do I work with half the energy? But what do I want to maintain? What is really essential for me? And the second question is, what do we have to let go in order to enable life for all within ecological limits? Well, it's quite obvious from the happenings over the last few days. Some settlements will have to be let go. We will not be able to live in all parts of the Alps because it's becoming too dangerous. We will have to let go of coastal cities because sea level rise will swallow them anyway. So let's think about what do we let go. And that also includes personal things. Like I personally think that we will have to let go of our individual cars. We will have to do with public transport and with rental cars but the individual car ownership is probably something of the past in the very near future if we want to achieve our climate goals. And the third question is, what can we restore that was already helpful in the past, or what can we learn from other cultures? And I think there's plenty of that as well. Here, for instance, our whole monetary system has run way out of control, and money used to be a method to enable trade. Meanwhile, it's become a commodity. So there are things we can change here. For instance, we could also give nature the status of a subject rather than an object in our legal system. That would make a huge difference about how we treat nature. So there's a lot of things we can learn. And I think if we answer these three questions together in a participatory manner for the institution, for the city, for the country, for the company, whatever, then we have a common vision of where we want to go, what we maintain, what we let go, and what we can take over again that we already knew once or somebody else has experience with. And if we have that common vision, then I'm pretty sure that we will also find ways to realize it, because then for the first time, I think, in a long time, we will all be working towards the same goal. And as long as we don't have a common goal, it is very difficult to reach it. Thank you very much for your attention.
Thank you very much, Professor Kromp-Kolb. There are so many ideas here, I guess. And so there are no questions in the chat. If anyone wants to ask something, this is the right time for commenting, discussing, expanding certain topics. I would leave it to the audience if there are some questions. Yes, there is a raised hand. Nicola, please.
Yes, I will ask a question from Christa Schleper, who excuses herself. She had to leave, and she asked specifically what we can do as universities. Her question is, I would be interested to know what spaces for exchange or opportunities we could create at the university for a change in lifestyle. One climate day a year is not enough. And if you know a format that works particularly well to get university employees and students on board.
Thank you for that question. I mean, I think you probably are aware of this iceberg model. The iceberg always only shows to a small part above the water level, and the main part is below water level. And above water level is these actions like a climate day a year. This is fine, it's necessary to create awareness, but it's not enough. The level immediately below is habit building actions. That is things like in Vienna, there's the action Wien radelt zur Arbeit. So you over the whole year, you collect how many days, how many miles or kilometers you have gone to work with your bicycle. That forms a habit. And the level below that is systemic changes. For instance, if we stay with the bicycle, is there a way to park your bike dry, not out in the rain, and rather safe? Nobody will take it from you. If you don't have that, if you don't have the means of parking your bike at your working place, then people will not come with the bikes. That is the third level. And the lowest level is the mental change. So it's not just about habits and opportunities, but it's also about what is important, what are my basic values. And I think we need, at university, we need actions in all four levels. I think we're not bad at the top level. There's all sorts of individual events and a lecture here and a lecture there, and that's fine. That's awareness building. I'm not belittling any of these levels. I think all of them are important. But if you just stay on this one level, then you keep organizing things, and you sort of exhaust yourself with organizing things, and you don't really achieve change because there's nothing habit building. And the structures are very much a question of how universities are run, what the governance look like, and what are the incentives to, for instance, save energy. If we at the BOKU, I don't know whether you have that too, at the BOKU we have a system that when you fly, you can compensate using projects that the university runs in Africa, other places. And the idea would be that every individual researcher knows if I get on that plane, I have to pay additional money to compensate the CO2 emissions. That would be the idea, trying to make those costs so high that it is more attractive to get on the train, especially for short distances. Well, it doesn't quite work that way at BOKU because they found it was too much administrative work. So they decided to take a rough average, and every department pays a lump sum for the flights they do. And that, of course, is nice, but it has nothing to do with habit building. It's sort of, yeah, an action which is happening at the department level, but most of the scientists who fly don't even realize that their flights are in some way compensated. But other universities, for instance, offer that the time you spend on the train is going to university or from university is counted at least to 50% as working time. Because in the train you can work, you can also think about your projects, about whatever. And it is an inducement to use the train rather than the car or the plane. So there's many different things that can be done. And if you look at the homepage of the Alliance for Sustainable Universities, it's an Austrian network, you find very, very many ideas what different universities are doing. And this network has the huge advantage that if one university does something and it works well, then other universities follow suit. And for instance, the Graz University started out with supplying bicycles to staff members at a very, very much reduced price in order to get them to come to work by bike. And the bicycles was visible, university, whatever, Technische Universität Graz, and the other universities followed suit. BOKU has BOKU bike, and BOKU started giving these bikes also, or selling these bikes also to students, again, at a very much reduced price, thereby enticing them to use the bicycle rather than cars. So there's many different ways of doing things. And of course, then there's the most difficult part, the lowest part, the mental mindset. That is something which takes long, has a lot to do with good examples that people who work at universities, I mean, you can try to teach students about energy and then you buy the electricity from some fossil fuel vendor, then it's not credible. So it has a lot to do with how is university run, what changes are. Do we have the parking lot immediately under the university or by the universities, or is this exorbitantly expensive? So people are really induced to come in different. But what food is served in the Mensa? All of these are things which help to change mindsets. What food is served for conferences, for workshops. There was a time, unfortunately it's gone back, but there was a time at BOKU when the rectorate had no official invitation with any meat on the buffet. It was all climate friendly. Yeah, and I think that's important. And if you don't do that, people ask, well, you call yourself sustainable and then that's what you serve. So credibility is an important part.
Thank you very much. There are two questions in the chat. I would read them for you. So Valeria asked, what is your opinion on the ways to communicate the emergency and the scale of the environmental challenges we already face and we will face in the future? People say that if messages are too negative, we'll actually stop other people from taking action. But how can it be kept positive without downplaying the urgency?
Yeah, that's a very difficult question. And it's one we've failed in so far, obviously. Otherwise, things would be different. My personal approach is to not downplay the urgency, talk about the urgency, talk about the danger, but at the same time, talk about the enormous positive developments that can be achieved apart from climate by good climate policies. So it's sort of saying that's the real danger, but you can also gain a lot by acting. It's not just avoiding the danger, but it's gaining, life's quality by positive action. And give examples, give good examples of, we talked about bikes before. I used to go to our institute by car. And together with my husband, he worked across the road at another institute. And we felt great because there were two of us sitting in the car, and most of the other cars had just one person in them. So we were obviously much more climate friendly. But then we realized that's not enough. And we bought tickets for the tram system, for the public transport, for the all year tickets. And that was great. But then we also bought bikes that can be Klapprad, I don't know what it's called in English, that you can fold up. And now we're going by bike plus public transport, and it's great. On a day like today, when the weather is fine, riding by bike is great. It's fun. And when you're going from university to some office or to some ministry or something like that, especially BOKU, it goes downhill. It's great. It's just pure joy. So I wouldn't go back to that car if you paid me for it. I don't know where to park it. It costs me the whole time I sit in the car is not relaxing. It's just getting mad at other people who don't know how to drive, because typically every driver is the only one who knows how to drive. Everybody else is stupid. No, but with bikes, and I think that is what we need. We need to show that the transformation is for positive, is for you gain in life's quality and in satisfaction. And I think that is what people really want. And that is how you can entice them to do something. But I don't think it's good to say, well, everything will be fine. It's not. There's no certainty of that. In fact, it's very much questionable whether it will be fine. So I think it's necessary to talk about the real danger and the urgency, but at the same time, describe how much better life can be and how much you gain also by sharing, for instance. We don't need to buy everything ourselves. We can share, especially at universities. There's a good opportunity to share things, whatever, clothes, instruments, whatever, and get to know people in doing so. So I think that is my approach. I don't know whether it's the right one, but it's the one I have chosen because just scaring people will just, get them close their ears and eyes.
Thank you very much. There is another question in the chat by Nils. To which universities would you point as role models who have already broadly discussed and implemented relevant and positive systemic changes outside of Austria?
Well, I think there's a few universities in UK that have really gone, but it's really, I don't think there's one well, maybe there's one university that has really a whole system approach, and that is in Germany. my names, my name memory. It'll come while I talk. But otherwise, there's many universities that have done great things in individual fields, but very few that have a whole system approach. In Germany, it's a private university that has really also offered for students in the first term, all students, independent of what studies they will do afterwards, they do interdisciplinary sustainability projects in the first term to introduce them to the concept, to introduce them to systems thinking, to introduce them to participatory work, and then they start with their own courses. And I think that's really, really very attractive. And it makes a huge difference for the way students go on through the years of university. Starts with L. I'll think of it. It's it's a question of age. After a certain age, you lose the memory for names.
Niels wrote Leuphana University.
Leuphana, exactly. Leuphana
yes,
University.
there is a link here also in the chat. Okay.
I think if I had to name one, that would be the one I would name. They also have their problems. And I think that's something you must acknowledge, that it's not easy to become the sustainable university. There's problems, any amount of problems, and they are also not great in all aspects, but they have this whole systems approach, which is something many universities are still lacking.
Okay, thanks very much for answering. Yes, Nicola is commenting. You just answered the question partially. In your book chapter, Why Don't We Act? You quote the sociologist Ortwin Wren, that there is a systemic underestimation of risks and that suitable governance structures are missing. Which governance structures do you think are needed on a local and global level?
Well, if we talk about Austria, I think one of the very counterproductive structures is the strong influence of Wirtschaftskammer, Industriellenvereinigung, Gewerkschaft, Arbeiterkammer, that are really part of the societal contract that was essential after the Second World War to rebuild Austria. But the questions that we now need to answer are not so much questions between workers and employers. It's other questions. It's questions like climate, it's questions like education. These are not questions between employer and workers. And therefore, this structure in Austria really needs to be changed, because I think that is blocking, and especially the employer's part, is blocking a lot of progressive climate policies in Austria. It's partly reflected in the ÖVP, but not only. It could also include the representatives for the farmers, for the agricultural sector. It's also blocking future developments, for instance, also in biodiversity. So this is one structure which I think definitely needs not to be abolished, but to be reconstructed and upgraded to include, for instance, youth, to include environmental representatives. So it needs to be broadened, and the influence of these two large sectors needs to be reduced, because they essentially make politics in Austria. I don't think we should be in doubt about that. Now, on the global level, we see a loss of influence of the United Nations. I think the United Nations would be an important player, or could be an important player. The same, the United Nations should be doing things which we now leave to the World Trade Organization, WTO, that are absolutely undemocratic. So I think there's these and geopolitics has considerably changed. I mean, all these institutions were built after the Second World War, when there was a dominance of the West, and especially the United States. And all these institutions and structures built in the interest of the important players at the time. And meanwhile, Asia, Africa, South America have just become much, much more important economically, but also politically than they were then. At that time, they were sort of just out of colonialism. This is not reflected. The United Nations has not reformed to keep up with the changing political and economic situation. I think we need to do that. We cannot continue to expect that the West can dominate and ignore the needs of the other continents and the peoples in the other continents, and just sort of benevolently admit one or two corrections, but not really talk at the same level with the governments of other continents, or the global South, if you want to call it that. So I think that this is something where we really need corrections, because that is what Ortwin Renn says, that we don't have the governance structures to solve these huge global problems. And biodiversity loss, but even more so climate change, is a global problem, and we will not solve it just by convincing individual governments to act. We really need global cooperation to do that. That doesn't mean that individual countries can do what they like. And I think Austria would be in a very, very good position, if it wanted, to take a lead and become an example of how climate policies could work, because we're rich. We have people that are very environmentally conscious, that are essentially have a good education. So Austria has good conditions, would have good conditions to become a leader, a world leader in these matters, but not if we don't do our own homework. As long as we don't do our homework, we cannot expect to influence the rest of the world.
Fantastic. Thank you very much. I don't see any other questions here. So I would like to thank Professor Kromp-Kolb for her talk today. It's been a real honor to have you here. Thank you very much. And I would like to thank the audience for joining today's talk. Thank you all again.
Thank you all as well, and especially you for inviting